G'day, welcome to Project Smith Tech, and if you like this sort of content, don't forget to subscribe. Now today we're going to look at expanded cards and just some of the advantages and disadvantages of a couple that I brought off AliExpress. Now, this card in particular is actually quite interesting. It has 24 ports, and it's claiming to have 16 by Gen 3 support. But if we have a little look closer, we're seeing, okay, there's not a lot of evidence there. However, the traces appear to be at 4 lanes. So 4 lanes, if that is actually true, you can get about, from my experience, you get 3,500 megabytes per second. And so that would be enough to do 7, assuming 500 each. And you get 7. Now, if you're running a mechanical hard drive, you could probably get that all the way up to, well, 10, I'd say comfortably, but 14. It wouldn't be a problem. Now, it doesn't mean to say that in a particular OS, so I'd definitely recommend this for Unraid. You could definitely fill this up. Now, it's not going to be super fast, but Unraid only uses 1 port at a time, essentially, depending on the operation that you're doing. So you could have, like, well, if you're gaining lots of data from all over the place, so you have a couple of users, you know, you'd expect to be able to access 7 drives at full speed, essentially, assuming that this is actual Gen 4. Now, if we have a look at the listing on AliExpress, yes, I know, not very professional using my phone. It is quite warm, so I didn't want to actually turn on the computer at the moment. But we go through here, as you can see, $216, which is quite a lot. I wouldn't actually pay that for it. As you can see what I paid for it, so I got it, that's total delivery plus taxes. I paid 166 AU. So these do fluctuate a fair bit on the market. Now, one thing I do want to draw your attention to is, yeah, just the chip that they claim. So if we have a look at Google, yeah, so that's the same chip. And it's only claiming 1, so that has got me a little bit worried. So I'm like, I don't know exactly, but I'll just go over quickly here, just if you wanted to. Okay, that's interesting, 1 lane, yeah. Anyway, so that, I mean, I'm seriously hoping it is. Now, if I wanted to be really professional, what I'd do is I'd actually stack it up full of the solid state drives, and I could definitely test it. I could make a, well, RAID 0 array and just do a quick, oh, I wouldn't even have to do that, actually. I could have the individual drives and just drive them all at the same time to find out if it's 1 PCIe lane or 2, because this board could be a generic board. So unfortunately, I won't know, but I don't have the spare SSD at the moment. So if it is 4 lanes, great. If not, I probably wouldn't actually recommend this card. But a card that I would recommend, and if you wanted to run this card here is basically, it's a 16 by Gen 3, which has a split out to 4. Well, we've got the SATA. You've got total of 5 SATA ports, so it's a M.2 converter to 5 SATA ports. Depending on how efficient these are, I'd like to believe that these could easily handle 500 megabytes per lane. So you can see we've got 2,500, and I know that a good Samsung Gen 3 drive can get 3,500 megabytes per second. So there's actually plenty of room in each of these, and this is a full breakout, so we've got 20 ports here. And what's significant about this, if you wanted to build a pool just on this card, you could easily got the capacity to expand your true NAS. And if we just have a quick look at the light, we can see that there's got, each of the ports has got its full lanes going to each of these breakout pieces. And so this one, yes, it would be a very high performance card, and this would be, I'd say, ideal for upgrading your true NAS. Now, keep in mind, you need a power supply that's going to power each one of these drives. So that could be a bit of a challenge. And finally, if you wanted to make a works pool with your M.2 drive, this is a Samsung that I just put here as an example. So basically it's the same as this board. However, without the, so this is just purely M.2 drive. And if we have a look at the traces, yes, you're going to get all your M.2 drives, you got to have your traces going, you got your 4 lanes going to each of your M.2 drives. So this I'd recommend using for your true NAS. Depending on your motherboard, you might have to make sure that you have bifurcation option as well. But I'm looking at this and I'm thinking, hey, this would be no problem. For this, I do find a little bit interesting. Well, when you go to bolt it down, I would recommend using the accessories that they've supplied to you. So you'd put, yeah, possibly this silver thing inside there. But as of today, this drive will be, I'm using this as a Linux partition on the 64 thread system that I previously showed on the channel, but I'll be running Linux this time, not Windows. Anyway, and for the final challenge of this video, I'm actually going to be editing off this little beauty here, which is the last video that I just made, which is the dual E5 2667 V4. Now, what is significant about this system is it is actually more powerful than the X58, which was a very popular video of mine. So I'd say, you know, I gave the prices of the chips, so I'd say that they're at least comparable in prices, and DDR4 should be relatively cheap at the moment. And a 1060. So this should be a very, well, I wouldn't say should be, this is actually a very cheap editing rig. Now, if I can edit this video using this system, I'd say mission accomplished. And mission accomplished indeed. All right, let's have a quick look at what's going on. Now for this, I didn't actually check, but for other systems, I did have to, what we call, go through, oh yeah, generate optimized media. There we go. Not bad. That's basically what I do for my lower end systems. Now for the 11900K, I haven't actually needed to do that, which I have found interesting. And we can look at this, like the video editor's not, oh, the video encoder, that's what's currently recording the very footage that I'm showing you now. CPU, it's barely doing any work. It's got a core going in there. No problem, there's heaps of more cores. This is actually a significantly better system than the X58. So that was a very popular video. So it's like, okay, well, this is actually a better system, and it's relatively cheap if you can get a cheap enough motherboard, and you don't have to go the dual processor. In some cases, that actually causes more problems than any advantage. Anyway, this is going to be edited in. I had no problem going through this whatsoever. I'm sure you don't want to, but you know, I've done all my cutting. Just quickly go through, I think I may have done a sensor. There we go, done a sensor here. So when doing a just a quick sensor, you can see it, I actually have to create another node. Add node serial, then you have to edit out one. Simple edit, but it does actually tax some of the system, and it had no problem doing that whatsoever. Anyway, hopefully this video is a bit of a test video, so I did want to actually just show some of the processes that I do here. Now, I know that I'm a very amateur video editor, but at the end of the day, you know, you got to start from somewhere, and I'm just a dude coming home from work that didn't want to go to bed early, so I do a little bit of YouTubing on the side. So thank you for watching. Anyway, back to the actual video. And that's all I wanted to share with you today. Thank you very much for watching. Project Smith Tech signing out. Peace. Just a bit of a recording of what 8K Doom looks like without any upscaling tech going on. And as you can see, it ain't pretty. And the display panel, if we can call it that, I don't know what's going on, but nah. It's a benchmark.